Let's look at this problem. Assume the municipal solid waste is 30% organic carbon. So, assuming that it's 30%, the municipal solid waste is 30% organic carbon by wet weight. So, the municipal waste, which is the trash that we trash from home. If you just look at this sketch, you see that trash is all the trash that comes down from your house back to the landfill. These trucks take it from your home and from the other industrial location to a landfill. Okay? So we're assuming that 30% of this waste is organic carbon by wet weight. The organic carbon in the solid waste decays. So this organic carbon in this waste, there's a decay. And this decay is following a first order kinetics. Look at this. Now we are following a first order kinetics after place in the landfill. What is a landfill? A landfill, it's a hole in the ground, and of course you have to have a liner. You have to have a liner, and they prefer a composite liner to prevent the fluid that will be created in the landfill. Okay? To prevent the fluid in the landfill that will be created from penetrating to the groundwater. Okay? So this liner was put to prevent leachate from going to the groundwater. And leachate is a product of the biological degradation of the organic in the waste. And the waste is here. You can see that the waste is here. So this is the trash. They trash it here and they do compaction. Okay? So after this, you can see that this is the liner all the way down. And when the leachate is being collected at the bottom of the landfill, they take it and then recycle it back. So this leachate is being recycled back. So you could finally treat also the leachate, which has a high organic concentration. Okay, so now the end product of the landfill is, of course, CO2, O2, and CH4, methane gas. All of this will be produced, and it will be great if we could have like electrical generation out of all of this, because this is natural gas, and this absolutely used in the US to generate electricity out of this natural gas. Sometimes they have, as we said, the leachate that's collected at the bottom could be recycled back, a bomb, so recycled back to the landfill itself. We don't want anything that will infiltrate to the groundwater. Okay? So he's assuming that 30% of the organic carbon by weight is the municipal solid waste is 30% organic carbon by weight. The organic carbon in the solid waste decays by the first order. So we know right now it's the first order kinetics after place in the landfill with the reported rate. Now, the dry climate, now we say that it's first order. Dry climate, what is dry climate? Like in the summer. In the summer, the K is 0.02 per year. In the moderate climate, K is 0.038. In wet climate, K is 0.057. Again, we know dry climate summer, moderate climate like spring, and wet climate during the rain, like in the winter. Okay? Dry climate is defined as, look at the way that he defined dry climate. It's defined as precipitation, rain, plus recirculated leachate. Remember? Rain plus recirculated leachate. Leachate that's being created because anaerobic degradation of the organic in the landfill. So precipitation and recirculated leachate being less than 20 inches per year. 20 inches per year. Okay? Moderate climate as precipitation plus recirculated leachate ranges from 20 to 40 inches per year. While wet climate having precipitation plus recirculated leachate greater than 40 inches per year. So we have dry, moderate, and wet climate, and he defined each one of them. He need now estimate the time. Estimate the time to take that it takes for 20% of the organic carbon contained in the municipal solid waste landfill to decay in 3 different climates. In practice, this will be a period when greenhouse gases should be captured from the landfill. Now, he wants 20%, and when is 90%? So now, we'll start solving this problem. Okay. You know the equation for the first order. So this is, since we are dealing with the first order, remember the first equation for the first order? C at any time t is equal C naught e to the power minus kt. Now, for 20%, so I will do it here. I'll do the equation here again. Ct or Cf or Ct is equal C naught E minus kt. Okay. For 20%, what did he say here? Estimate the time. He needs the time for 20% of the organic carbon contained in the municipal to decay in 3 different climates. Okay. So he needs 20% removal. What is 20% removal? If we say that C naught, let's say here, if C naught is 100, what's 20% removal of 100? 80, right? So this is e to the power minus kt, and you could make it as this, 80 over 100, e to the power minus kt. Okay, so now, this is 0.8 e minus kt, and then you could ln both sides, ln 0.8 equal minus kt. So the time is equal ln 0.8 over minus k. So this is for 20%. Now let's do for 90%. If C naught is 100, 90% is being decay, means that 10 is remaining. If we assume C naught is 100, so 10 is here. E minus kt, and we could do the same thing. 10 over 100, E minus kt, and then 0.1, E minus kt, and then ln 0.1 minus kt. So T is equal ln 0.1 over minus K. So this is what? This is 90%. So now we have to use the climates. Okay? We have to use the climate. Now, for dry climate, what was the dry climate? Dry climate, climate. K is 0.02 per year. For dry climate, K is, what was K? 0.02. K is 0.02 per year. So we will make it like this. T, the time for 20%, I'll make it 20 like this, and T for 90% removal. T for 20%, it is ln 0.8 over minus K, and T90 ln 0.1 over minus 0.02. Okay. So the first one, it's 11.2 years. The second one is 115 years. It makes sense because when people put trash in landfill, you can see to get 90% removal of the organic, it will take 115 years, a lot of times. To get only 20%, that's 11.2 years. Landfill is not the right place for this trash waste. We have to recycle. As we said before in the class, take the food composting, take the paper for paper recycling, take the plastic for plastic recycling, and take every piece of solid waste into recycling if you want to reduce the number of years to get rid of all of this solid waste. Now, you could do the same thing. You could do the same thing for the other climates. So this is the dry climate. If you want to use the other climate and compare, you could do that. So you could do this. Let's say this is dry climate. Now the moderate climate. K is 0.038. And you could put K here as what? K here as 0.038 and 0.038. Okay? And check how many years it will take. What do you expect? Of course, in moderate climate, you will get too many years for this waste to be degraded, to completely removed this organic. 90%, it will take a lot of years if it's moderate climate. What will happen if in wet climate? 0.057. What will happen in 0.057? Same thing, number of years will increase humongous. Because of course you'll have more water, more leachate, and then you'll have more circulation. So this is the end of this example, and hopefully you'll understand this question. Thank you.